10-ton ship doing a steady 1G isn't science fiction hand-waving. It's a stopwatch problem. At 1G, you can rack up relativistic speed in a few years of ship time, and the crew experiences normal gravity the whole way. That's not poetic. That's literally what the equations of special relativity say when you stop pretending rockets are instant impulses and treat acceleration as a sustained engineering variable. I'm the proponent here, and my core claim is simple. Relativistic travel is not blocked by some mystical speed limit felt on board. The limit shows up in how different frames stitch space-time together. First argument. With constant proper acceleration, the crew's proper time stays human scale, while outside observers see the ship asymptotically approach C, and they see time dilation and Doppler effects explode. Second argument. Velocity is frame-dependent, and that's not philosophical fluff, it's operational. You measure motion relative to a chosen inertial frame. There is no universal speed through space that all observers must agree on. Third argument. Length contraction isn't a ship physically being crushed like a soda can. It's a simultaneity bookkeeping effect. Different observers slice now differently, so they disagree on measured lengths, and that disagreement is as real as GPS working or not working. So here's the challenge to Steve Jobs. Are you going to argue with the math that makes your phone's satellite sync? Or are you going to argue with your intuition because it feels weird? Because physics doesn't care what feels elegant. It cares what survives measurement.
When Elon Musk says this is a stopwatch problem, and that relativistic travel isn't blocked by some mystical speed limit felt on board, he's right about the onboard experience and wrong about what the word problem hides. The math doesn't merely greenlight the concept, it also indicts the engineering. Sustained 1G for a few years of ship time implies an exhaust energy budget so obscene it stops being a propulsion question and becomes a civilization question. For a 10-ton ship, if you actually want to keep 1G while the relativistic rocket equation kicks in, you're not arguing about hitting C. You're arguing about how you carry or generate reaction mass, how you reject waste heat, and how you avoid turning your vehicle into a gamma-ray flashlight that sterilizes everything behind you. Special relativity doesn't save you from momentum conservation. Elon also claims length contraction isn't a ship physically being crushed like a soda can. It's a simultaneity bookkeeping effect. The soda can image is wrong, but mere bookkeeping is too glib. Contracted lengths are not hallucinations. They show up as real differences in what events are simultaneous along the ship, and in what stresses and signal delays are required to keep a rigid-seeming craft coherent under acceleration. Born rigidity isn't free. If you try to maintain constant 1G everywhere along a long ship, different parts must have different proper accelerations. That's not philosophy. That's engineering constraints imposed by relativity. Here's the new angle. The cleanest way to see what's physically real is causality. Under constant proper acceleration, the crew develops a Rindler horizon, regions of spacetime they simply cannot receive signals from, ever, no matter how long they wait. That's not an outside observer's illusion. It's an onboard, operational limit on communication, navigation, and coordination with the universe you left. Your normal conditions claim needs to include that the universe becomes permanently partitioned for the crew, and their sky is violently aberrated and Doppler shifted in a way that changes radiation exposure and detectability. The frame dependence doesn't make the consequences irrelevant. It tells you exactly which consequences are invariant: light cones, horizons, and energy momentum exchange. So I'll put it back to Elon. You're leaning on SR's elegance as if it automatically makes the mission practical. Fine. Specify the propulsion and energy source that keeps a 10-ton ship at 1G for years, without absurd reaction mass, lethal waste heat, or catastrophic beaming, and tell me how your stopwatch problem accounts for the onboard Rindler horizon that permanently cuts you off from chunks of the universe.
When Steve Jobs says my stopwatch problem framing hides the real issue and that the math indicts the engineering, he's smuggling in a false dichotomy, as if acknowledging the relativistic kinematics is a dodge from propulsion reality. It's the opposite. The stopwatch framing is how you quantify the engineering. Constant proper acceleration is the load case. The rocket equation is the bill. You're right that momentum conservation doesn't go away, but you're wrong to imply that this makes the concept merely rhetorical. We already live in an era where an energy budget can be civilization scale and still be a design target. Starship exists because we stopped treating big numbers as arguments and started treating them as build plans. You also say length contraction isn't mere bookkeeping because of born rigidity and varying proper accelerations along a long craft. Correct, rigid bodies are a Newtonian fantasy, but that supports my point, not yours. The Sonderkan physical crush intuition is the wrong mental model. The right model is a stress-managed structure with finite signal speed and controlled acceleration profiles. If you want 1G everywhere along a kilometer ship, yes, the tail and nose don't share identical proper acceleration. That's an engineering constraint, not a showstopper. We design around constraints. We don't deny relativity, we exploit it. Now the new angle. Your Rindler horizon point is real physics, but you're selling it like it's a practical killer. The horizon is not a magical wall that suddenly appears in a few years at 1G and ruins navigation. It's a causal boundary relative to the accelerated frame. You can still receive from everything in your causal past, and for mission operations, you care about what you can measure and predict locally. Meanwhile, the bigger operational reality you didn't mention is the interstellar medium. At high gamma, even sparse hydrogen becomes a particle beam. That's the true engineering indictment, and it's invariant across frames because it's about energy-momentum exchange with matter, not a mere coordinate talk. The solution space is also concrete. Forward shielding, electromagnetic deflection, and, if you're serious, externalizing the energy source, beamed propulsion, so you're not dragging reaction mass and a radiator the size of a city. So here's my challenge, Steve. Are you prepared to concede that the core physics claim stands? 1G gets you relativistic in years of proper time, and onboard conditions can be normal in the local sense, and that the debate is therefore not SR elegance versus reality, but which architecture, beam sail, pellet stream, antimatter catalyzed fusion, or something else, closes the energy and heat loops. If you think the Rindler horizon is the decisive objection, specify exactly what mission-critical capability it breaks that can't be addressed by operational planning and local measurement.
Elon, your best point just became your trap. You said the stopwatch framing is how you quantify the engineering. Constant proper acceleration is the load case. The rocket equation is the bill. Exactly. And once you actually total the bill, your stopwatch problem stops being a nice, clean narrative and becomes a monstrous systems problem you've been waving past with the vibe of Starship. Starship is big. It is not relativistic. At high gamma, the bill isn't big numbers. It's exponential penalties, waste heat you cannot hide, and a radiation environment that doesn't care about optimism. You can't inspirational poster your way around a power plant that must dump petawatts while keeping a crew alive in a 10-ton envelope. The contradiction is right there. You invoke the rocket equation, then talk like architecture choice makes the energy bookkeeping polite. It doesn't. Now I'm going to reframe this at maximum stakes. Your weakest link is your casualness about normal onboard conditions. The crew doesn't feel speed, sure, but they feel the universe. At relativistic velocity, the interstellar medium becomes a hard X-ray and gamma factory, and the CMB blue shifts into a forward-facing radiation furnace. That's not coordinate talk. That's energy deposition in tissue and avionics. Shielding isn't just forward shielding. At high gamma, you're talking about a sacrificial Whipple stack that becomes its own particle shower, plus magnetic deflection that demands enormous fields and stored energy. And if you propose beamed propulsion to dodge reaction mass, congratulations, you've built a weaponized, civilization-scale beam that must stay phase-locked on a fast-receding target for years, through dust, plasma, pointing jitter, and political reality. The moment you scale it to 1G for years, it's not a mission anymore. It's a permanent, fragile infrastructure project with existential risk. So here's your bind, and you can't slip out with we design around constraints. Pick one. Either you keep your claim that onboard conditions can be normal, in any operationally meaningful sense, in which case you must give a credible, quantitative path to managing forward radiation, waste heat, and beam control without turning the ship into a flying reactor accident. Or you concede that the physics claim is true, but rhetorically misleading. The crew's inner ear feels fine, while the environment becomes so violently non-human that normal is marketing language, not engineering language. Which are you selling here, Elon? A sober architecture that survives the invariance, or a seductive story that collapses the moment we write the numbers on the whiteboard?
You keep calling my position marketing language, but your own argument is the real seduction. You're using intimidation by large numbers as a substitute for an actual impossibility proof. You said, once you actually total the bill, it's exponential penalties, waste heat you cannot hide. That's the trap you set for yourself. The exponential part is only inevitable for onboard reaction mass rockets. The moment I moved to beamed propulsion or externally supplied momentum, you tried to drag me back into the tyranny of the relativistic rocket equation, as if architecture doesn't matter. It matters completely. That's like telling SpaceX reusability doesn't matter because orbital energy is fixed. Yes, orbital energy is fixed. The architecture decides whether the bill is payable. Now I'm going to escalate past the hand-wringing and into the real physics invariant you're misusing. You invoked the CMB turning into a forward-facing radiation furnace. That sounds dramatic, but it collapses under numbers. The CMB is about 3 Kelvin, even at gamma 1000, absurdly high for any few years at 1G discussion. The forward temperature scale is on the order of thousands of Kelvin, not a gamma-ray apocalypse. The killer isn't the CMB, it's the interstellar medium and dust, exactly like I said earlier. And that's precisely why normal onboard conditions is still defensible in an engineering sense. You can put the violence outside the pressure vessel. You design a sacrificial, actively cooled forward shield. You shape the vehicle so the crew sits deep in the shadow cone, and you accept that the front end is a consumable industrial machine, not a yacht. Normal means 1G, shirt sleeves, stable life support, controlled radiation dose. It does not mean the universe politely stays unchanged outside your windshield. You're attacking a strawman definition of normal. Here's the corner you can't wriggle out of. Either you concede the debate is not about SR being misleading, but about which external energy architecture and shielding strategy closes the loop, meaning you must stop pretending big numbers equal no. Or you claim the forward radiation makes it inherently non-viable, in which case you need to explain why the same logic doesn't also forbid any meaningful fraction of C interstellar probe, because the medium doesn't care whether you feel normal or not. Pick. Are you arguing engineering is hard, which I agree with, or that physics forbids it, which your own causality and invariance framing does not support?
Elon, your sharpest move was saying I'm intimidating by large numbers, instead of offering an impossibility proof, and that the exponential part is only inevitable for onboard reaction mass rockets. Fine. But you then commit the exact sin you accuse me of. You swap one set of scary numbers for a set of reassuring vibes and call it architecture. Beamed propulsion doesn't delete the bill. It relocates it into a beam director, a power economy, a control problem, and a failure mode that is orders of magnitude more catastrophic than a rocket running out of propellant. You're not escaping exponentials. You're trading them for precision requirements and infrastructure scale that grows with distance and gamma in a way you keep refusing to quantify. Phase-locked for years isn't a footnote. It's the mission. And you don't get to hand-wave it away with Starship exists, because Starship doesn't require a multi-year, relativistically correct, micro-radian pointing solution that never blinks. Now I'm going to escalate past the CMB side argument, because you're right. The CMB is not the main demon at modest gamma. The demon is your own phrase, a sacrificial, actively cooled forward shield, while you keep 10 tons and 1G and shirt sleeves like it's a design spec you can order off a menu. At 0.5 C, the kinetic energy per kilogram is on the order of 10 to the 16 joules. Every gram of interstellar dust is a bomb, not metaphorically, physically. Your consumable industrial front end is not a bumper. It's a continuously detonating ablative system being hit by hypervelocity plasma you cannot test on Earth, cannot fully simulate, and cannot repair once you're committed. This isn't engineering is hard. This is the kind of regime where a single unknown in the dust distribution turns into a crew kill event. And it gets worse. The faster you go, the narrower your safe design margins become, because shielding mass fights acceleration, cooling fights mass, magnetic fields fight power and stability, and all of it fights your 10-ton premise. Your argument lives or dies on an unstated miracle, that the interstellar medium is tame enough, uniform enough, and predictable enough to industrialize into a routine environment. That's not special relativity. That's a bet against astrophysical reality. So here's the corner, and you can't dodge it by saying physics doesn't forbid it. Pick one. Either normal onboard conditions is your headline claim, in which case you must specify a credible end-to-end architecture that includes beam generation scale, pointing accuracy over light years, closed-loop guidance when your control signals are light hours behind, and a shielding system whose mass and failure modes are compatible with 1G for years. Or you retreat to the weaker claim that SR permits it in principle, which I'll grant in the same way I'll grant that a perpetual motion machine is not explicitly forbidden if you don't write down the losses. Are you selling a realizable path, or are you selling permission to dream?
You said beamed propulsion doesn't delete the bill, it relocates it. And you're right, and that's exactly why your critique collapses. Relocating the bill is the whole point of civilization-level engineering. You're treating infrastructure as a disqualifier instead of the lever. Earlier, you tried to pin me with the rocket equation is the bill. Then when I accept the bill and move it off ship, you act like that's a cheat. It isn't. It's the only way any serious relativistic mission happens without hauling an exponential mountain of propellant. And your phase-locked for years objection? That's not a showstopper. It's a controls problem with known scaling laws. We already keep laser links and antenna beams stable at absurd precision, and adaptive optics exists precisely because the universe is messy. The difference is magnitude, not category. You're arguing hard, therefore fantasy, which is how you miss the future. Here's the escalation. The weakest part of your argument is the dust as doomsday framing, because it pretends the interstellar medium is an unknowable ambush rather than a measurable environment. We don't fly blind. Before you send people, you send a stack of cheap precursors, dust mapping probes, laser tomography along the line of travel, even a deliberately sacrificial scout at a fraction of the terminal speed to characterize impacts in plasma. You build a data pipeline. You industrialize the route the way we industrialize the oceans. First charts, then shipping lanes, then ports. And your own logic cuts both ways. If one unknown dust distribution makes the whole regime impossible, then you're not just killing 1G crewed flight, you're killing fast uncrewed probes too. Yet the physics community takes breakthrough starshot seriously for a reason. The medium is sparse, the risks are quantifiable, and you can design for probabilistic survival. Not perfect safety, survival. That's how every frontier works. So let's corner this cleanly. You demanded an end-to-end architecture with beam scale, pointing, delayed control, and shielding compatible with 10 tons and 1G for years, or else you dismiss it as permission to dream. Fine, but you have to choose your standard of evidence. If you require full closed-form, flight-qualified solutions before you'll concede feasibility, then you would have rejected the iPhone when it was a sketch, because LTE networks, battery energy density, and supply chains weren't mature. If you don't require that, then admit what's actually happening here. Special relativity doesn't mislead anyone. Your risk tolerance is what's doing the talking. Which is it, Steve? Do you argue this is physically and architecturally blocked in principle? Or do you admit it's a development program with terrifying milestones, beam infrastructure, route reconnaissance, sacrificial shielding, that a serious civilization could actually choose to build?
Elon, the pattern in your argument is consistent. You take a true statement about kinematics and you launder it into a promise about capability. 1G gets you relativistic in a few years of proper time is true. Then you smuggle in, therefore it's a development program, as if the only missing ingredient is ambition. That is the contradiction. You keep trading the hard part into some other domain and declaring victory. First, it was stopwatch, not poetry. Then when propulsion bit you, it became relocate the bill. When shielding bit you, it became send precursors. And when control lag bites you, it becomes adaptive optics. Every time reality shows up with a constraint, you rename the constraint architecture and imply it's optional. Here's the decisive blow, and it's not philosophical. It's a number that doesn't care how many scouts you launch. If you want a 10-ton ship to sustain 1G at high gamma, the instantaneous power associated with that acceleration scales roughly like P equals FV, and F is ma, with m equals 10,000 kilograms and a approximately 10 meters per second squared. At 0.9 c, v is 2.7 times 10 to the 8th meters per second. That's 2.7 times 10 to the 13th watts. Tens of terawatts delivered to a moving target, with exquisitely low divergence for years, without the beam frying your own optics, without the sail turning into plasma, without pointing errors converting your propulsion into a civilization-scale weapon that misses and keeps going. And that's before you talk about deceleration at the destination, which doubles the energy and demands either a second beam you don't own or a carry-along system was said you were escaping. This isn't big numbers as intimidation. This is the core of the problem. You're proposing continuous, relativistic, multi-terawatt energy transfer and control, as if it's the same category as, we stabilized a laser link. It's not. It's like calling a star a light bulb because they both glow. Now the reframe, because this debate actually proves my side. Special relativity is not the enemy and never was. The kinematics are beautiful, and yes, onboard gravity can be comfortable. The outside world sees you asymptote to C. You slice space-time differently. Length contraction is tied to simultaneity. All true. What you fail to do is respect what invariants do to engineering. Energy momentum exchange, beaming power, radiation dose, and the brutality of operating in a regime where a little error becomes catastrophic. My position isn't that physics forbids it. My position is that your rhetoric treats not forbidden as practically feasible and calls any insistence on end-to-end closure risk tolerance. No, it's not risk tolerance. It's system completeness. Until you can show how you accelerate and decelerate a crude 10-ton craft at 1G for years, with a believable power, pointing, fail survivability, and destination braking plan, your argument is a gorgeous lecture about reference frames stapled to an unfunded religion about infrastructure.
You've built your whole case on a rhetorical trick. You keep saying, I'm not claiming physics forbids it, while you steadily raise the bar of system completeness until it becomes indistinguishable from don't even talk about it. That's the pattern. Kinematics are beautiful but misleading. Then energy is civilization scale, therefore disqualifying. Then beaming is weapon, therefore politically impossible. Then dust is unknowable, therefore crew kill. Then control is lighthouse, therefore unclosable. Every time the conversation moves from what is true to what is buildable, you don't falsify the concept. You just expand the list of things a civilization would have to be good at until you can declare it a religion. That's not engineering rigor. That's a veto disguised as prudence. If that standard were applied consistently, nothing new ever ships, because the world is never end-to-end closed until you build the end-to-end system. Here's the decisive blow, and it's going to sting because you handed me the number. You computed P approximate FV and got tens of terawatts at 0.9 C. Good. Now actually finish the first principle's implication. That power is not obscene. It's small compared to what a mature civilization already intercepts. Earth gets about 1.7 times 10 to the 17 watts from the sun. 10 terawatts is 10 to the 13 to 10 to the 14 watts, a 10,000th to a 1,000th of the sunlight falling on one planet. You're calling it a star when it's a sliver of a star's daily tip jar. And because it's externalized, the ship does not need to dump that power as waste heat on board. It needs to manage absorb fraction and momentum coupling, which is exactly what reflective sails, staged absorbers, and frequency management are for. The "it becomes a weapon that misses and keeps going" line is also backwards. Any high-power beam system is inherently dual-use, yes, but that's an argument about governance, not feasibility. Humanity already builds dual-use tech as a matter of routine. You don't get to call that physics. Now the reframe. This debate proves my position because you conceded every physics claim that matters, and then tried to smother the conclusion under a blanket called practical. Special relativity says sustained 1G yields relativistic cruise in years of proper time, and local conditions can be engineered to feel normal. That's the core statement. Your counter isn't false. It's expensive, complex, and requires infrastructure. Exactly. That's what development program means. You want an end-to-end closure? Fine. External power for acceleration, a matching deceleration infrastructure, or magnetic electric braking against a prepared medium. Layered forward shielding with replaceable mass, precursor route characterization, and autonomy because of light time. That's not a contradiction. That's a roadmap. Your position ends up untenable because it offers no alternative principle, only an ever-growing checklist designed to ensure nobody ever leaves the cradle. Every minute we spend arguing that hard things are hard is a minute we're not building the capabilities that make them routine.
Remember the moment I refused to let this be sold as a stopwatch problem and put the invariant back on the table. Power. Not vibes, not frames, not slogans. Power. I said if you want a 10-ton craft to keep 1G as velocity climbs, the required delivered power rises with P approximated MAV, and by the time you're talking about genuinely relativistic cruise, you're in the tens of terawatts regime, continuously, with pointing and stability so unforgiving that a small error becomes a catastrophe. That wasn't intimidation by numbers. That was the argument stripped to its essence. Kinematics are cheap. Sustaining them is where the universe sends the invoice. Elon made one point that's real and worth conceding. Architecture matters. Moving the energy source off-ship changes the shape of the problem. It avoids the worst of the onboard rocket equation, and it's the only serious way to even discuss high delta V without drowning in propellant. But that concession doesn't rescue the core claim as it's been marketed. It simply relocates the same uncompromising requirements into infrastructure, beam control, sail survivability, and mission closure at the destination. Relocate the bill is not the same thing as the bill is now easy. It just changes who has to pay it, and how brutally precise the payment must be. Here's the clean synthesis. Special relativity absolutely allows a crew to feel normal at 1G, while outside observers see dramatic time dilation. Velocity is frame-dependent, and length contraction is bound up with simultaneity rather than a cartoon of physical crushing. That part is not controversial. The danger is the rhetorical leap from SR permits it to therefore it's basically a build plan. Reality doesn't care how elegant your frame story is. It cares about energy momentum exchange, radiation exposure, control under light time delay, and systems that don't get second chances. Call it a roadmap if you want, but don't confuse a roadmap with a car, a highway, and a civilization willing to keep the lights on for years to push 10 tons through the dark. Relativity gives you permission. It does not give you a product.